Hi, Philip. Welcome back.
Hi, Adam. Thanks for inviting me again. It's good to be back.
And you are the double P, Philip.
Yes, double P, Philip. I think it's the most common in German language. I don't know.
And are there also Philips with double L and one P? No.
There are. I think in English-speaking countries, it's the default way of spelling it.
And one L and one P?
I have seen it, but very rare.
Okay. Because I look at your first name, and I think I also saw double L and one P, and I was confused. Was it just my hallucinations, or is it real? But yeah, perfect. But you are the real Philip, the real deal.
Not an LLM hallucinated, Philip.
Yeah, very. I don't actually know. I see your face, but who knows? Yeah, almost perfect. Maybe you're on vacation, somewhere on the beach, and or vacations in Seattle. With yeah. But Lambda Power Tools, and you are really eager. And what you did is you thought about getting rid of Aspect J, and you introduced a nice concept. And I think we should introduce today logging and metrics because they are somehow coupled, and also your refactoring. So just to try. So in the past, I didn't like AWS Lambda Power Tools because of the Aspect J. And what Aspect J is actually a great concept. So what you could do with Aspect J is you can introduce your own annotations, and Aspect J reacts to that and generates code behind the scenes. It is actually similar to Lombok.
It is
right
yes.
now. I never saw this, but actually, it is very similar to Lombok. It is really old, the Aspect J, and what I don't like about that is that it generates code behind the scenes. That's all, and it's another framework we have to look at. And I also burned from the past because it was very popular, and in all my projects I had to justify myself to clarify why I'm not using Aspect J. It is so great, and I'm ignoring it. And back then I couldn't see the use cases except logging. So actually logging fits perfectly. Performance measurements, whatever, is a typical decorator pattern in Java, right?
Yes, it is. So I say one of the value propositions of Aspect J is that you can offload a lot of work to the build time phase. Mm-hmm. So you can implement these cross-cutting concerns by injecting code at build time into the Java bytecode. And then you don't need reflection at runtime, for example, to detect these kind of annotations. So from a performance point of view, it's a good way to offload things at build time, which is why we decided in the past to use it for Power Tools for AWS Lambda, because it's beneficial for Lambda to offload as much as possible to build time rather than startup time.
I think it was back then also the right choice, because I think Aspect J is the only one like framework neutral approach and most established approach. This is the most standardized thing you can do to apply aspects or additional functionality without reflection.
Yeah, that's true. There's one, I think when Aspect J was released, it didn't exist, but there's also ByteBuddy. That's, for example, used by Mockito for mocking things in unit tests. This can also modify bytecode at build time, but then you need to write your own Maven or Gradle plugins to inject it.
But ByteBuddy is, I think, would be more controversial, because the Aspect J follows the AOP, aspect-oriented programming, with lots of books, documentation. So if someone mentions AOP, everyone thinks about Aspect J. So it was, I think, the right move back then. But what evolved, we have, for instance, frameworks like Quarkus and CDI and Micronaut, which already ship with standard interceptors and way of decorating the methods. So I would say what we could think about is to make the access to utilities very simple, like interfaces with static methods, and then it is a breeze with Quarkus, for instance, what I use daily, is to implement if I like a own interceptor or invocation handler, which talks to the utility And also, we could still keep doing aspect J, but factor it out, right? So we say, okay, you can use the Lambda power tools, and if you really like, here's the aspect J or whatever, byte body, whatever you have, annotations, and this is a little bit nicer. This, I think this is as for me, would be better because I actually reviewed the code of metrics, a little bit of logging, and it's simple. It is a clean code. You can read it as Java beginner. I think it's understandable. There's almost no magic. So yeah, this were my thoughts about Aspect J. Mm-hmm.
Yeah, I thought about it as well after our previous podcast recording. So what I would like to offer to users of Power Tools for AWS Lambda is to have essentially two ways of using it, as you mentioned. One way would be still the annotation-based way, and the second way would be having functional interfaces that allow you to initialize the different utilities very easily in a way that doesn't require any configuration in your building tool chain. But instead of keeping aspect J for the annotations, I'm planning to follow a similar approach to what Quarkus is doing. So they are offloading some tasks to build time, and they actually open sourced two great utilities outside of the Quarkus framework. The first one is called Yandex, and the second one is called Gizmo. So what Yandex does is it can build an index of your source code at build time, and then you can retrieve annotated methods very quickly at build time in, for example, a Maven or Gradle plugin. And then Gizmo is a higher level abstraction of ASM, which can be used to inject things into bytecode at build time. And it's heavily used inside the Quarkus framework for these kind of build time code modifications. So what I envision is for customers who want to use it, we can offer a Maven and a Gradle plugin, Aspect J free, to allow customers to use annotations. And once we have such a plugin, we can also think beyond just annotations. For example, we can collect the classes that customers are using and preload them when they are using snapstart, for example, using crack to reduce startup time. So these are kind of things that make a lot of sense doing at build time. And this is a modern stack. And once Java 25 becomes the baseline, we can even reduce the dependencies further by using the class file API.
These were also my thoughts. And what you did right now, you summarized why I'm only use Quarkus for serverless. These are exactly the reasons. Because Quarkus internally doesn't use any reflection and its startup times are very fast. And if you look at I don't know whether you had the chance to take a look at the constructions cloud.
I just had a look at it this morning, yes.
Yeah. Okay. This morning I released the HTTP API gateway, and I'm 50% done with EMF. So there will be soon also an EMF with the new utility, hopefully. Example: how to capture the metrics, and if you would look at the implementation, the interesting part is it is absolutely Lambda independent. It is basically a Java monolith, but Quarkus optimizes the monolith. So in my projects, we can write the old code, and Quarkus with Lambda optimize that. So and we don't have to care about this, right? And what I think the killer features of Lambda Power Tools, which are actually there are lots of, but I think the most, I thought to call it the foundation for me is EMF first, because two reasons. So in Java, Prometheus is very popular. And but in order to run Prometheus, we could expose with Lambda the metrics, which make kind of sense, because if the Lambda is destroyed, the cache of the metrics is gone. But you could still use a basic metrics as long as the Lambda is alive. So because in order to scrape the metrics, Prometheus will call the Lambda, which is an additional call. In a warm Lambda makes sense. In a cold Lambda, it doesn't make any sense because you will see nothing, right? So this is a half. But even if you do this with Prometheus, we have to install Prometheus there is a managed Prometheus on AWS, but we have to do this. But with EMF, it is not a standard approach. It means my clients are concerned about dependency on AWS. It's like, yes, we are depending on AWS, but this is like one-liner, and we can absolutely put it somewhere. So I would say the amount of code you need to have a metric is even less than the standard approach, and we don't have to install anything. So this is like, a balance between dependency and in my opinion, if we are on AWS, we should use AWS because it's a kind of paranoid, to be on AWS, not use it. Because if we move somewhere else, then it's easier. Yes, it is easier, but we have to write more code and maybe even, pay more, like for the metrics. So metrics are killer feature. And the other one is interesting and subtle, is the parameter store, which maybe we can cover next time. Parameter store. And why? Because it is not obvious, but the parameter store's standard tier has a throttling limitation, right? And I think it's like 40 transactions per second per account, which you could hit. And there is no need, to access every time the parameter store because it doesn't change that often. Actually, in my projects, usually it never changes because this parameter store is also populated with CDK. So only in rare reasons like secrets, whatever it is, but you are not allowed basically to change the parameter store in the console because usually it's a part of the process. And we use parameter store just to share data between stacks. It's not like and have maybe overview. What's the configuration for a human, so that we say, okay, there's a table with this thing. And the Lambda Power Tools caches the parameter store. So you don't have to go to the high throughput and the professional tier. So Lambda Power Tools helps you to write more cost efficient way. So and this is interesting because the EMF uses structured log behind the scenes, and this is where your refactoring started. So if we cover both for today, we cover a little bit of refactoring and also the metrics and embedded metrics format and structured logging, right?
Yeah, that's a good point. Also, one other thing for the parameter store, it also handles the deserialization. For example, you can store some complex objects in cells in the parameter store as well, and then as a JSON string, for example, and then you can also deserialize it, which can also save you calls to parameter store if you have some complex things that you would like to store, and then you can have it retrieved in one call.
It's like object JSON binding, like Jackson style.
It's Jackson binding, yes, and it also supports JMS path functions for extracting specific things or your own transformations if you want to base64 encode things. So it's we're trying to cover a lot of use cases.
Regarding the metrics, so how this works behind the scenes, the EMF is based on logging, and this is why we need structured logging. So maybe we should start with structured logging first. I also have some criticism. If you like, I created issues for that, but
yes,
now
always
issue first. Issues are a bit dangerous, right? Because if I create issues, it's not rude, but maybe I'm influencing the project in a wrong direction, right? So it is always, I think for me, it is good to have a chat first and then write a better issue. Because you could misunderstand something or your strategy and write an issue and change the course of the project in the right direction. So this is in the wrong direction, not the right direction. So this is a little bit problematic with issues and such decisions, right? But I think I will write it because let's start with my criticism maybe to logging, very similar to metrics. So you are using behind the scenes SL4J facade. And I think it is possible to get rid of the dependencies. And what I'm doing, and actually I'm doing this in all my constructions.cloud examples, I'm using the built-in, it's a lesser known, but built-in Java system logger. And the Java system logger is used eternally by Java. And what it is very similar to SL4J. It is the abstraction, and the default implementation is java.util logging.
Mm-hmm.
So which means with that, we can get rid of external dependencies, which is a good thing. So this is the main criticism of that.
Okay. So you mean using java.util logging as the
not
facade?
util logging, Java system logging. This
Java system logging.
Yeah, system has a log, so you don't need even there is a Java system logger, and this is in this Java Lang package. It ships with Java 17 or whatever, so it is pretty old actually, and it uses behind the scenes Java util logging, but you can swap it, so you get for free a facade.
Mm-hmm. And do you know if I can swap it with log4j or logback backends as well?
It never did it, but it should work because it is meant to be swappable. So this would be because I'm pretty happy with Java util logging, and to be honest, on Lambda I just use system.println.
Mm-hmm.
But then it would be not usable, maybe not as good usable for Fargate, right? Because I think you could use the Lambda AMF utility with some adjustments for Fargate as well, right? For ECS.
I don't know. I think you can, yes. So
I think you could. So this would be but this is a different story because AMF on Fargate is also nice. And I look at the code, it could work. In the past, I implemented it by myself, but after getting rid of asset J, we think we could also reuse the metrics for ECS Fargate if we. But for Lambda, actually, the craziest option would be just to use system.println. It would be a bit, I don't know whether it would be dangerous because the Lambda could be multi-threaded if you start these threads and you log, by yourself. So you get some throttling, but I think you will get it anyway because the print stream is synchronized. So I don't think you could have a multi-threaded logging to CloudWatch, right? So this would be an interesting investigation. But what I do in my project, no kidding, I have an interface with info and so forth, and behind the scenes the system.println. That's all. And this would be the first. If we can do this, go for that. If you need more, parameter replacement, whatever, I would take a look at Java System Logger, and I would write an issue maybe just to as a reminder, right?
Yes, please do that. I think it's an idea worth investigating.
Yeah.
Of course, we also have to think about what are Java standards in terms of logging, and SLF4J is quite established. Mm-hmm. So probably we will not go and abandon SLF4J completely, but offering lightweight alternatives is already happening throughout the library. For example, log4j and logback, they are independent modules. You can just plug them in and they are loaded using Java service loaders. And potentially we can do something similar for Java system log that you just described.
And the system is from Java Lang system, right? So this is the crazy part. So it is really the very lightweight approach. And what I can tell you, if I show this to developers, it is always taken. They say, okay, nowadays it's cool, but because all the logging frameworks were popular outside the cloud, and sometimes even what projects try to do is to switch the log levels in running system. I saw crazy solutions with threading and reloading the loggers, which is impossible, which is a good thing in immutable architectures like Lambda. So I would say in the cloud, we need far less, right? So of logging functionality, we only need to write as fast as possible to CloudWatch, and this is basically it. And maybe sometimes I have a very few log levels, like maybe info that you would always like to see this, and debug in debug mode. So this is usually you can survive projects with that.
Yeah, I think this is a good point that you're making with info and debug mode, because one of the features of the structured logging that we offer in Power Tools is log buffering. So with log buffering, you can emit info logs by default if you set the log level to info. And if an exception happens in your code, or you can also opt into whether you log an error message, you can flush all debug logs that are associated with that specific request. So essentially, you can emit info logs by default, not worry about log ingestion costs. But if you have an error, you have all the context you need from your debug logs without having to configure anything except for adding a line in your log4j or logback configuration. So these are smaller things where we can leverage the logging frameworks easily because you have this configuration approach. That's
But does the buffering, I took a look at the code, really is helping performance? Because Lambda has to wait until the buffer is written, right? Because it is written asynchronously, I guess, or what?
Yeah, so we always, we forward the debug logs to the respective resolvers of the logging frameworks, and then we buffer them in a buffer that's per request of the Lambda function. And when the Lambda handler exits, we either drop the buffer, or when an exception occurs, we flush the buffer. So essentially, we keep track in the background asynchronously of all the debug logs that are emitted, but we only print them to standard output
cool idea.
if
So now I
something
got
happens.
it. Okay.
Yes.
So what it means is that the debug logs are kept in memory, and on demand they are flushed. This is great.
Exactly.
Idea.
You can also flush them manually if you want to. So,
but what I did, I had a parameter store parameter, but I had to redeploy the Lambda. Of course, you also have to redeploy the Lambda, and it was just a switch. You can say no if debug mode, don't do anything. So why you pick the version with buffering? You know that the design decision.
I didn't understand what do you mean with switching the mode?
Yeah, if you write what I had is simplistic, and interface with a starting method debug, and inside the interface there was if and debug, and the value of the debug was basically environment variable in Lambda.
Okay.
And this was provisioned with CDK, which was absolutely transparent, of course, because in CDK I could say okay, and this could be overridden by code build, because we knew okay if there is a trouble, so we could just push a button, code build redeploy Lambda with debug, and there was no debug at all, it was just removed from the code base. And your approach is a little bit more sophisticated, so which is by the way great idea, but there should be other reasons. It would be interesting why it is implemented like it's implemented, because I thought maybe it is the performance inside the requests that you could. Maybe this is the thing. If you buffer your request within the if you buffer logs within the request, we could work multi-threaded and hit CloudWatch only once. This is actually the reason, and the next reason you can save costs, the API invocations, because you are not calling CloudWatch over and over again. You call it once.
I think so. CloudWatch, in the case of Lambda, when you print something to standard output, the Lambda service handles the delivery to CloudWatch. So you even for metrics or logging, you never call the CloudWatch API yourself, and you also don't pay for any API calls. So it's delivered on your behalf by the Lambda service. But in our case, the reason is not necessarily about performance. It's about reactive versus proactive. So in the scenario you described, it's a reactive approach. I have a problem in my Lambda function. I want to investigate further. So I change the parameter in my parameter store to debug, and then I have debug logs which help me identify the problem. But in our case, it's a more proactive approach with the log buffering feature, because you deploy the Lambda function once. By default, you emit info level logs, but without changing any configuration, if an error happens, you already have the debug logs flushed to standard output. So they appear directly in CloudWatch, and you don't have to wait until the error happens, then enable debug logs, then debug the error. In one go, you have all the logs associated in your error context.
I have to steal the idea in my projects without Lambda power tools. So what it means is you are writing all the debug statements to a buffer, and the buffer is exception listener. And on exception, it flushes everything, the context.
Exactly.
Which is great.
Either exception or on a log.error. You can choose.
This is huge, actually. This is a great idea. So, because I read the code, like, why they are buffering? I don't get it. But now the idea that you actually flushing the entire context you gathered until the point, if something really happens, is great, of course.
Right? Yeah. And it also works not only with info and debug. You can choose any combination of levels that you want to buffer. You can also say, I only want to emit warning and error by default. And as soon as the first error happens, I want to flush all info and debug, or only info but not debug. So it's very flexible.
Mm-hmm. But we could use this debuffer also for system logging, right? Because we could implement the buffer by ourselves.
Yeah, the buffer is actually implemented by ourselves. It's just how the buffer is filled. It's filled by resolvers, a log4j resolver. Mm-hmm. That's essentially a small appender, and you can wrap any log4j appender in this buffered appender, and then it will buffer, for example, debug level logs. And so it's actually a standalone feature, because it's not only working for appenders that print to standard output. It works for any appender. You can theoretically have an appender that streams logs to a Kafka stream and still use the buffering feature.
Now I'm just thinking about the buffering, so we have to quit the podcast right now, because it's a really cool idea. So that the buffer is as an exception or error listener. This is great. And we could still do my approach. It doesn't prevent you from that. It's a complete different approach. And your explanation is great, reactive. Yeah, it's perfect. So what? And now I'm in for loop while true, but
while true buffer.
why true buffer and how to change my project? Okay, my feedback I wanted to give you. I was involved in many serverless Quarkus projects, and we never use an external framework. So what happened is, at the beginning of the projects, we use system.println just straight. Then we saw how it goes, and they say, okay, now we can introduce our own interface with nice methods. It was interface logging, logger, or whatever, dot static methods, info, whatever. And in this interface, we use system.println, and sometimes we introduce additional parameters to capture more stuff, right? Sometimes we wanted just to, for instance, to write JSON for debug purposes. So there was a logger with JSON as parameter. So it make as convenient as possible. But behind the scenes, right now, it was always system.println. There was not even need for system logger. So this is my feedback. And in code reviews, I also perform a lot of code reviews. If I saw external framework in Lambda, I asked the architects, developers, why you need it, and there was no answer. So I never heard a reasonable answer why we need external frameworks in Lambda environment if you have CloudWatch in place, because all the arguments from the past are different now in the clouds, because we get more services and all the redirections working. So this is maybe listeners will give me feedback if we publish the episode on LinkedIn or somewhere. So it's highly appreciated. But the idea would be to delete as many dependencies as possible. And log4j is quite large, right? So this is a big dependency.
Yeah, that's true. Logback is more lightweight than log4j too. Those frameworks, they have a lot of features, and as a library developer, of course, you also need to think about different use cases to bring customers to a place where they can implement the features they need. So that's why we usually like to offer a good choice of different implementations, and then the customer can choose. And what you just suggested might be another way that we can offer customers who need less features and want to follow a more lightweight approach.
I'm working as a consultant in companies, and what often happens is when I arrive in projects, they have a set of dependencies they always use, right? So they say, okay, we have to use log4j, is our decision. So I get now, but if I migrate the project from on-premise to cloud, maybe we should review the dependencies and change our mind and do something different in the cloud, other than lift and shift is not always working. And by challenging that, we are able to delete all the dependencies. I think what happens often, they say, okay, we need log4j, we need this other, because we cannot migrate to the cloud without that, right? And this is a clear requirement, and then you implement the requirement. But I'm in a situation that my clients fire me for architecture, so I challenge everything. If you hired me, now you have it, right? So why we do this? Why we do this? Why we this? And what is the idea behind that? And then we can simplify code, which is always good for maintainability, and in the Lambda case is very good for speed. And this is why I always using Quarkus. And the only reason why I'm not using Micronaut, maybe I mentioned already, because Quarkus is a microprofile base, so there are more standards involved, and all my past projects were microprofile, so it's very easy to migrate to cloud, right? So this is the thing. And Quarkus automatically redirects the system out println also. If we use internal Quarkus logging framework, it also works with Lambda. The system out println is handled by Quarkus and then redirected to whatever, right? So it works perfectly.
Mm-hmm. Yeah, that's a good point. I mean, one other point is the thread safety. So in PowerTools, we also have a batch processing utility where you can process batches from Kafka streams or SQS messages. And you can also process them in parallel. And one challenge, if you do system out print logging, for example, would be you have to implement the thread safety yourself from the context that you add in your structured logs. So, for example, if you...
But system out println is already thread safe because the print line is synchronized. So it's
synchronized,
safe.
Yes.
This is the problem.
It's too thread safe.
Thread safe, yes. You get throttled with system out println. So there was actually back then, prior to clouds, so on premise, if there was highly concurrent application, one system out println could destroy the performance, right? Because it waited and there was lots of threads waiting to access that.
Yeah. Mm-hmm. So what I meant was if you add, let's say, a key in your logging context, mm-hmm. let's say this is the Lambda invocation for user ID 123, mm-hmm. and then in my thread I add other keys, you need to take care of not leaking this context yourself mm-hmm. across the different threads if you have some global state or something in your mm-hmm. application code. So all of this in the case of PowerTools for AWS Lambda would already be handled for you. Mm-hmm. That this logging context is always thread safe, no matter if you're handing off the multi-threading to some other code that you might already have in your business mm-hmm. logic and you bring it to Lambda.
Mm-hmm. And this could also change in the future with the structured concurrency and scoped values, right? So what, because I think you referred to the nested diagnostic context, right? This was the feature of logging.
Map diagnostic context, yes.
Exactly. And MDC, exactly. And in some projects, what was also used was thread local to transport the data. And thread local is going to be replaced by, I think it's called scoped values. It's like the possibility of virtual threads to do that. And virtual threads will also work great with Lambda because, yeah.
Yes, so I'm really looking forward to being able to use scoped values within the library as well. But our current baseline is Java 11 because we also move, in line with the Lambda runtime availabilities. But I'm looking forward to adopting more modern Java features as well. For example, scope values.
Would it be possible to offer AWS Lambda on the edge, right? Not on the edge like CloudFront, but just the newest Java 25. I mean, to introduce such a concept on AWS. I know that this is conservative because I think in serverless, where speed means efficiency, it could be a valid approach, right? To say, okay, look, we have a Lambda version. It only supports the latest LTS, mm-hmm. Java 25, and we have backward compatibility, but not features are available. And why? Because of serverless. So this was I think it's easy to justify why, and because otherwise you have to wait until 11 is no more supported, and this is way too long. You're missing out of lots of features.
Yeah, I mean, it's not, we don't have to wait until 11 is completely deprecated, and I think it should be in 2026. Last time I checked the Lambda documentation. So it's not that we have to wait for 5 more years or so until that Lambda runtime is deprecated. But yeah, I think it depends a bit on what you want to achieve. Do you want to achieve giving customers a standard way of using logging, metrics, and other serverless patterns? Or do you want to start differentiating between customers who want to be on the newest edge of features versus customers who might run on older Lambda runtimes still? And this adds a lot of complexity to the library development and also to the way how we can receive open source contributions. So I think it's a trade-off we need to think about. I can't give a straight answer in the podcast.
No, absolutely not. This is just inspiration.
We had some thoughts about similar things already, like launching a labs version of Power Tools, so where we can experiment a bit with features before they graduate into the library.
And I think Lambda is different because what I do, all my projects are in Java 21 because it's CDK, Java 20 and LTS, and I'm waiting and waiting for Java 25, and it will come. I will immediately switch all projects, right? So not immediately, first with my constructions cloud, if it is working, I say, okay, this focus and so forth is working, so the chances are very high it will be available everywhere. And usually, if you don't have that, the problem is if you have Docker container, for instance, you have to pick a JDK. This is on you, to build the Docker image, and then it's more problematic because maybe you are afraid of upgrading to the next point release, which happens in the case of Lambda anyway, because I'm just saying pick Java 21 and I get the latest patched Coretto at the next deployment, right? So I would say what I tell my clients, we have always deploy as soon as possible on Lambda, and there was no resistance. But on Docker or Kubernetes, different story. They are afraid to upgrade. So this is a different mindset. So I think, I think I don't know, you mentioned Java 11. So I can imagine there are legacy Java 11 projects which are almost forgotten. They are running and the clients don't like to upgrade because they don't know how or whatever, right? But I would say in modern development, I think with serverless, it is a good thing to educate the clients and customers and say, look, we always pick the latest LTS, and this is already how to call it how to call it more laid back approach, because I could use right now with Java 26, and I'm not talking about that, right? So this is like the latest LTS, and we are not on the cutting edge, but we can always use the stable features, and Java is also faster. So Java 25 is a little bit faster than Java 21, so you can even save money.
Yes, it's. I think one reason is also the compact object. But just going back to my point from earlier, what was it? Now I lost the thread. Oh yeah, the Java 25, educating the customers. So you can become one of the first customers using the functional interface of Power Tools, because this will work with Java 25 from the beginning, because one of the reasons is that AspectJ doesn't support Java 25 and the project is not very actively maintained. So I think it's a good thing that this happened, because now it kind of forced us to implement this functional approach, which is something that I linked in this issue. You also commented this morning. I linked a feature request from 2022 about exactly this functional way of using it without AspectJ. So now, by coincidence, we make it compatible with Java 25 from day one, and we offer a new interface for using the library without AspectJ.
I took a look at the approach. Great idea. So what I understood is you called it middleware chain, which is Gang of 4 chain of responsibility almost. So you can put the node processors, like there was logging metrics or whatever, and it just delegates. So my feedback was the middleware term in Java. If you mention middleware in enterprise projects, everyone thinks about application servers. So this would be not very good for marketing. And if we just call it, Power Tools chain and dot whatever and Power Tools, I think this would be, we don't have to mention what it is. It's just, like Apple Mail. I use the mail, and this is Power Tools. I use the Power Tools. So this was my minor, reaction to that.
Mm-hmm.
And I really like the approach, especially if you look at metrics. Is basically you have to bootstrap the library by yourself, which I think is a even good thing, because in Quarkus I would put it in application scope post construct and add the liner here, and I will have a logging input, and I see when it was called, and this is less magic, right? So this is more magic from Quarkus, which I have anyway, and I can just use the entry point to the library. So I really like where it is going. So, and there's also the nice fluent interface, also perfect. And yeah, I'm glad that actually you are now the chief of Power Tools, because this happens a lot in recent weeks, and it goes to the lightweight direction. So more Java 25 features, less external dependencies, how it should be. So I'm misusing Lambda, as a runtime for simple Java projects, basically, and this works well. So I reviewed the metrics code a bit, and some reflection is used. So what I saw is that the context field is set to accessible true in order to access that, and you could actually also use the Quarkus technology to get rid of the reflection entirely in metrics. So this will be also a good thing. So if you go to metrics and search for set accessible, you will find. And this is, I think, won't be necessary. You can save some performance because reflection is slow. I mean, it is still crazy fast, but with the Gizmo approach, whatever we could get rid of that, And yeah, this is about metrics, or about metrics. For the listeners, maybe CloudWatch EMF, just to repeat that, what you can very easily do to create your own counter, let's say, and if you and make it available in a dashboard in a CloudWatch metrics. So this is how it is, and how it works is that Lambda Power Tools creates a JSON message which uses structured logging behind the scenes. So this is the other library. And this specific format, and back then it was specific MIME type, I think is still required for this logging event. CloudWatch says, oh, this is something special. It parses the log and creates the metrics on the fly. So it means you don't need to scrape, with another tool to get the metric. You get the metric immediately.
Yeah, that's true. Just to go back to your reflection point. So when I revamped the metrics utility for the Power Tools version 2 release, I removed all reflection. So Perfect. The current version is actually completely reflection free. I think maybe you looked at the code in the V1 version of the utility.
So I pulled, I have my, it's okay, I just pull the recent changes, and maybe this was V1, yeah.
Yeah, I saw this, and then when I refactored the utility, my first thought was, how can I get rid of this? And I found a way to do it. And now we have EMF as a metrics backend, and are also open for adding new metrics backends. So EMF does not have to be the only metrics backend that's supported. It's the only one supported today in Java. But in other utilities, we also support different metrics backends. For example, in Power Tools in Python, we have Datadog as one metrics backend as well. But going back to your point about the JSON and EMF, so what actually happens is when you create a metric, it can be number of orders in your business application, and then you can have a counter. It will emit structured JSON. If you see it in your CloudWatch logs, it starts with _ AWS. And this follows a specific format, which batches all the metrics in one JSON blob, prints it to standard output, sends it to CloudWatch logs, and then CloudWatch logs will parse it and create a metric in CloudWatch metrics. So you can create graphs or add a widget to your dashboard to track these kind of metrics. And this is usually, a good way to keep track of business KPIs coming from your application that are not necessarily related to default metrics that are emitted from services like API gateway, HTTP status codes, for example. But these custom metrics, they are quite useful for tracking your application relevant business metrics. And the good way with EMF is you never have to take care of calling an API. You don't have TCP traffic. You don't pay for API calls. You just print something to standard output, and it's only flushed once per invocation at the end of the handler when it runs. So it means you are not constantly printing to standard output, but it will batch and then flush once.
Yeah. And also you don't have to run your own Prometheus server, right? Because everything's integrated. So this is the biggest deal because, what I like about the approach, so there's a micro profile metrics. They were standard, and they from the beginning had actually two registry of metrics. One was system and the other one was application. And the system metrics were more about, garbage collection and memory consumption and so forth. And the application metrics were business. And in all my projects, I ignore, the system registry because you can create pretty dashboards, but you still don't know what happens in the applications. And we started with a view meaningful counters. In fact, most of my projects are based like on the BCE idea, boundary control entity, means we have components with nice names, and every such component is significant functionality for the business. And I say, okay, if this is so significant, I will expect at least one counter per component. Order happened, I don't know, payment happened, payment validated, payment successful, payment not successful, stuff like that. And this maps directly to metrics, EMF metrics. This is what I usually would just increase counters. And I got another idea. What we could do is we could introduce error counters. In case on an error, I could flush additional metrics like, performance, whatever, which only happens if error happens, right? Because then I will see a chart. It's like, okay, so now something happened. I can look at the dashboard. This would be also possible, right?
I think it would be, I think in this case, we're back to the annotations again, right? So ideally, what would be nice is if you had something where you have a method and you annotate it with @error counter, for example, and then it will automatically count this metric and then add it to the EMF blob when it gets flushed. For this, AspectJ is of course again a choice, but Quarkus doing it at build time, this way. But interesting point that you mentioned it. So microprofile also has an annotation @timed.
Exactly.
So you can track how much time a method takes. And they are actually also using AspectJ, which I was really surprised to read in the documentation.
It depends on the implementation. As you're free to whatever. So one point of time there were a microprofile implementation that used Netflix Hystrix, the deprecated framework even. So this is it really depends what you pick. I think there is a small array metrics is one implementation. Another microprofile implementation is from Glassfish as one. So there are lots of implementations, right? And if they do this, I will have to talk to them. Why you're using AspectJ. By the way, AspectJ is great. AspectJ not so. So
yes,
AspectJ,
yes.
yeah. And another thing, one of the killer features of structured logging, you can actually ask that it will show you the cold start. This is actually interesting. How are you doing this?
So what we do is we have a module called Power Tools Common, and this keeps track of certain things that happen around your Lambda handler. So what we can do is, without any dependency, we can just track when the Lambda runtime, when the execution environment gets deployed for the first time. All your Java classes are uninitialized. So we just check when your handler runs, we initialize a fake class. And if this class was initialized when your Lambda handler starts executing, we know it was not a cold start. And if it was uninitialized, we know it was a cold start. So when we bootstrap this map diagnostic context, we just add cold start true or false based on whether this class was initialized or not. So it's a very small trick that requires very few lines of code.
Perfect. So another while true, cold start loop in my brain. This is really useful because there's lots of discussion, in Lambda, how bad is cold start, how long it takes, and this actually solves the problem completely. So another thing, which this was also a fresh idea. So if you get Gizmo and you get the Quarkus technology in Lambda or similar technology, it doesn't have to be to Quarkus. What we could do is actually we could pick the standard annotation Java X inject, for instance, which is available in Maven and CDI and everywhere, to inject Lambda context, right? So you don't have to use the parameter. You could also make it injectable, or in a subclass. So we could have a subclass which implements whatever and make it injectable without reflection. So because the problem with add inject Lambda context or parameter, the HTTP, what's called the HTTP API gateway event or whatever, without reflection is impossible. But with bytecode manipulation is very possible. So I think it could work. The problem, if you have a subclass, you have to tell the Lambda runtime, use my subclass from AWS Power Tools, and which I use in the case of Quarkus. How it works is I register the Quarkus handler, and Quarkus deals with me with the reflection, whatever. That's the entire trick. And we could have something like lightweight Quarkus built into Lambda Power Tools. So we could have the AWS Lambda Power Tools handler. This would be a subclass of a generic Lambda. And with bytecode manipulation technology, we could inject stuff which could make what you will get almost like nice little servlet or how to call it or event listener, basically, which with supported dependency injection, right?
Yeah, I like this idea. I was already thinking about this some time ago. But one problem is if we generate classes, for example, using annotation processors, if we generate new classes, you also have to update your CDK code to reference this new generated class that doesn't exist in your code. So it might be a bit confusing for customers who are not very deep in the Java ecosystem. And the second thing is, even if we did this, the way your Lambda handlers are executed is the Lambda Java runtime, which is on GitHub open source project, is actually orchestrating all of this handler execution. So we don't control how the handle request method is called. This is actually implemented by the Lambda Java runtime. And there, of course, it's quite hard to make assumptions on how customers are using it. So they have to follow like a very strict request handler interface, which you need to implement to specify your Lambda handler. And there it's true, they are using reflection for detecting the type that you use in your handle request method. For the Lambda context, they don't need reflection. They just inject it because you implement the interface. But there's also a reflection-free approach that you can use, and this is the request stream handlers. You can actually write a handler that gets the raw input stream as input, and then you can take care of deserializing everything yourself. So this would be a reflection-free approach how you can use it.
Just an idea. I mean, this is the Lambda Power Tools 3 or 4, but I think it would be very possible with technology. It's not that hard.
Yes.
with a reflection would be a weekend project, right? There's actually this is really nice, but to make it correctly is of course more to do.
Well, now that we talk about it, maybe if customers using this feature, we can modify the handler in place and replace the reflection-based handler with the non-reflection-based handler and inject code to handle the deserialization. So it looks like it's a reflection-based handler, but it's actually not, because it gets transformed and the deserialization is offloaded to the Power Tools library. I should create an issue for this.
So now on your idea, which would also be interesting, is we could make the deserialization mechanism pluggable then. Because what I don't like is the strict, dependency on Jackson, which Jackson is fast and great, but still big. And then you can say, okay, just, this is my function stream, and I'm responsible for deserializing this, right? So I could add additional logic, so this could be more into it, and we could also use, the service loader approach or not, depends. It doesn't matter, to make it pluggable, and then you also future-proof, right? Because it's okay. We could have Jackson-free support.
This exists today. It's called Lambda Custom Serializers.
Maybe Mark Sales was involved, right, in this project, I think, as well.
Oh, I don't remember if he was involved in this project, but it's in the official Lambda documentation, and this is how we make the Kafka utility possible. We register a custom serializer on behalf of the user, and when the request arrives, we know how to deserialize things using protobuf or avro encoded messages, because our serializer is called, and only if it's not a Kafka request, we proxy to the Lambda default serializers. So this is actually already working today.
Because what also happens is Java will likely get java.util.json support, very lightweight parser based on records. So there is already a reference implementation, or a reference in the implementation. There is a proof of concept by Paul Sanders. So we covered this in the recent podcast. And so then we could have, built-in Java deserializer. So, just thinking about this, because the events which we get from Lambda, they have almost always the same structure. They are trivial, actually. So we could have even a Quarkus-based hard-coded parser, right? We don't need, because we exactly know what's coming in. So we don't need a generic parser. We need a parser, and what we will do is just extract the detail. And now it's a little bit complicated, because in some cases the detail is your choice, but we could pass to the applications that detail a string, for instance, right? So because and then this is up to the application to parse the detail, for instance. So just idea. So this is, I got the idea right now. If you talk about that, but this would be another benefit, I would say. And even if sometimes in the first iteration, if I use event-driven lambdas without Quarkus, I introduce a mistake, usually, always, with deserialization. And by the way, what I'm using usually, I have one, and so the lambda is just with object, I register with object. Then I have a next method where you can have pattern matching. So, okay, is it of right type? If it is, then I use JSON reader from JSON P, and I'm reading actually the object. And then as soon as possible, then I have a method Java record from JSON, and it just populates itself, and then I get the event. But in the process, usually the two iterations are my mistakes, because the level of deserialization, whatever. But with AWS Lambda Power Tools, I say go now in debug mode and show me, the deserializations, or the deserializer could add additional features. And if there is null pointer, whatever, it will dump actually what was wrong, right? So this will also an additional feature with a custom, custom AWS Lambda Power Handler, which is based on the non-reflection. How does called streamable? No, stream handler. What is it?
Request stream handler.
Request stream handler. Exactly.
Yeah, it's another interface that you can also implement, and then your handle request method gets an input stream and not a deserialized object. we have something similar already. We have PowerTool serialization, which is another standalone module. And you can extract this detail object that you mentioned from almost all AWS Lambda events, SQS event, for example. You can automatically extract these detail objects and transform it into your Java record or Java class. But yeah, it's true, it's using a JSON. But since we have control of this, once this JSON-P becomes a standard, we can migrate away from JSON for this.
JSON-P is the current standard in microprofile, and what I'm talking about is java.util.json. This is no name right now. Java.util.json, and there is just a proof of concept in OpenJDK project. And this to watch JSON-P is too controversial because the microprofile, we have to just use microprofile, whatever. So, but the Java.util.json, this would be just a standard set in stone if it ships because it will be part of JDK. So, if the performance is okay, we could just use it. But yeah, maybe last question regarding CloudWatch. What I found out, if you're writing structured logs in text format, so I mean, just you have always the same pattern. Often this is good enough to do, and you can find a lot with CloudWatch built in. So this is usually good enough. You introduce the JSON structured. So I also asked the questions now at conferences regarding CloudWatch. So if you log in JSON to CloudWatch, are there benefits regarding performance, whatever, to find the right thing? But or is there any difference if you have, let's say, comma separate approach, not comma tab separated logging to CloudWatch or JSON? Are the benefits of using JSON?
Yes. So the benefit is that you can write queries for deeply nested JSON. So if you have a JSON log, you can filter by, let's say you have a JSON that's not flat, but deeply nested, because in PowerTools, you can also log arbitrary maps or objects.
Nested
JSON.
Nesting is the big difference. Because
and there you can filter by product.id in your logs insights query, and it just works.
Okay. This is stellar answer. The nesting. My logs were not nested. And if you introduce nesting, then of course, because it is impossible to express in one-liner. So this is getting messy. So you will have to do multiple lines with standard logging, and you can have one JSON message, right? This is the huge difference.
Yes. And also if you want to just filter for a key in a flat JSON, this would also work. You can just say filter message and then cold start equals true. And then you have all cold start logs for your Lambda handler. And
but
then
this works also well if your text log is also structured, right? So you can also filter easily. So this is what I had no problem with that, because what I did is I had often costs logger who calculated the costs for every request, because I knew there's API gateway, whatever. So I had no knowledge about the entire thing. And then I could easily filter, for costs, and CloudWatch did it for me. So this was less of a problem. But with the nesting, you're right. So this is nicer, and I thought it is a more performant search, but I'm not sure about that. But yeah, thank you. So it was I got a lot of idea right now, which I can steal from Lambda PowerTools to my projects. And back to your statement regarding EMF. I'm actually introducing EMF right now, and if Java 25 is supported, I will change at least my examples, if not projects, to completely use EMF. So this will come. And in one of my production projects, we will introduce EMF very soon.
Wow, happy to hear it.
So this is, yeah.
So one note also about the EMF implementation of PowerTools is that you can maintain a singleton that you can inject, for example, using Quarkus CDI. And this is thread safe, which is not the case in the EMF Java library that's available on GitHub as well. So if thread safety is something that you need, you can even do it with a singleton using the PowerTools metrics factory.
Yeah, perfect. Great conversation. I will write an issue, a friendly one regarding system logger with pointers to Javadoc. And I have to invite you back because I'm also involved there too deep with serverless right now in my project. So it is easier to have a chat, and maybe some of the listeners would like, to review or contribute or whatever. And so for me, it's a huge time saver, a podcast with you. So this is
That's cool. Yeah. For me, it's also a great way to talk about some deep technical stuff. I hope the audience can follow it.
absolutely. The audience is stellar. So and it's my podcast, so they have to follow, right? So what they can do. So thank you a lot. Where people can find Lambda Power Tools or you on the internet?
So Power Tools is on docs.aws.amazon.com/powertools/Java for the Java version. And we also have Python, .NET, and TypeScript versions available as well.
But Java is the best. So that's what I say. You have no opinions,
Of course, as Java tech lead, I am completely unbiased.
Yeah, exactly, completely unbiased. So I'm also unbiased. So I reviewed all the runtimes. Java is the best, which is I didn't review anything, but just Java. But yeah, just fun. Okay, and do you also are on Blue Sky, LinkedIn, or Twitter? So
primarily, I'm on LinkedIn
with Philip Page.
Philip Page, yeah.
Page or Page.
Page when I speak English, Page when I speak German.
You can say you are the famous Jimmy Page, guitar player, and and people say, wow, it's pretty cool, and but I say it's not as cool as AWS Lambda Power Tools tech lead. So thank you a lot, and see you next time.
Thanks, Adam. See you next time.